All right, here we are back again. I have my son, Ethan.
Hello there.
He's going to help me out. And we're going to be learning some topics on thinking and language today. It's chapter 10 in your book. Um, Here we go. All right, the first thing. Thinking is cognition. And the term cognition simply means mental activity associated with thinking, knowing, and remembering.
Pretty
Okay?
much using your brain.
Using your brain. Anything that goes along with using your brain. That's cognition. Good.
Any part of your brain.
Any part of your brain. That's right. The cognitive psychology is the study of these mental activities. So if you're a cognitive psychologist, you would study how do people make concept formation, problem solve, how do they make decisions, and how do they make judgments about things.
You know, once my teacher told me that they were doing an experiment on a dog, and the mental activities of the dog, pretty much your left side of the brain actually controls the right side of your body,
Yes.
and that's basically what you're studying, right?
Good. You got it. Let me see, I got to move to the next slide here. All right, so some terms to define here. What is a concept? Okay, a concept is a mental grouping of similar objects, events, or people. It's a way we sort of create a category. As we learn something new, we create a category, and then we base all of our new information of objects by that category. And I'm trying to find an example here because it escapes me. Chair. So if I said chair, you have a concept of a chair. Everybody's concept of a chair might be a little bit different, but we all basically know that within that concept, a chair basically is a thing that people use to sit in, and it usually has four legs. Okay, but within those confines, you can have a wide array of possibilities. All right, and where am I? And this is where we get prototypes, is a mental image or best example of a category. Okay, so when I say chair, you probably have a prototype of a chair in your mind when I say it. The first, the most like a chair. Okay.
An image in your mind.
In your mind, you're right. Okay. So you're matching new items to the prototype, and it provides a quick and easy method for including items in a category, as when comparing a feathered creatures to a prototypical bird, such as a robin. So for most of us, if I said think of a bird, most people think of a robin-type bird or maybe a cardinal, but a bird that's usually relatively small, and it has all the main features of what you consider a bird. Most people don't immediately think of an ostrich, which is a bird, but much larger than your average bird, and it can't fly. Or they don't think of a penguin, which is also a bird and doesn't have feathers.
Well,
I don't think it has feathers. I don't know. But anyway, it can't fly either. It spends most of its time either on ice or in water. So prototypes help us get the best idea of a category. And now we're talking about how we solve some problems here. Algorithm. Okay, is a methodical, logical rule or procedure that guarantees solving a particular problem. Guarantees. If you follow the algorithm, you're going to solve the problem. Okay, it's the study of both logical and illogical thinking. Contrast with the use of heuristics, which I'll define here in a moment. Computers. You always hear that somebody saying something with computers, like I designed an algorithm and so-and-so's checking to see if some problem will be solved in a certain amount of time, and that's great. That's exactly what computers are great for, is algorithms. They'll take these long processes and work them out fairly fast. But I have some examples here of algorithms. Here's a basic one. So we start at the start, and you say, do I want to do this? If the answer is no, you move over, you follow the algorithm there. It says no, don't do it. What if it is yes? Well, then you go to the next block down there, I guess diamond, and it says, will it likely end in disaster? Okay?
Why are you looking at me when you say that?
I was just talking. I was just trying to include you in the broadcast here. Will it likely end in disaster? If the answer is no, like here, then you do it. Now, if it says yes, will it make a good story anyway?
That's
Okay.
a horrible boss.
If it says yes, then do it anyway. If it says no, it won't make a good story. If it'll end in disaster and it won't make a good story, don't do it. So that's a basic algorithm for do we want to do this? Okay.
Who makes these?
Well,
Take out that block. It's terrible.
okay. All right. Here's another algorithm that probably many of you don't think of. This is a recipe for chocolate chip cookies. It's an algorithm.
Great.
If you start with the beginning, that they tell you how to start with it, get the ingredients, set the oven to a certain temperature, make the cookies the way they say to make them, and then cook them for an amount of time, you will end up with hopefully this result right here of this nice looking cookie that tastes good. Okay?
Thanks for making me hungry again, Dad.
No problem.
You better make me another grilled cheese sandwich after this.
Okay. But basically it is an algorithm. So a recipe is an algorithm to come up with some food. Now, contrary to this is a heuristic. Heuristics are rules of thumb, okay? Thumb. Strategy that often allows us to make judgments and solve problems efficiently. You're not going to always get the correct answer. You're not going to always solve it just right, but you can be much more efficient with heuristics, whereas an algorithm might take a very long time. Okay, usually speedier, okay, but more error prone, and then sometimes we're unaware of using heuristics because we use them all the time.
So basically it's trying to solve something.
Right, both algorithms are solving things and heuristics are solving things. Algorithms do it one way, heuristics do it faster, but you're more error prone, and I'll explain why. Okay, a rule of thumb. So a representative heuristic is a rule of thumb for judging the likelihood of things in terms of how well they seem to represent or match a particular prototype. Okay? It may lead one to ignore other relevant information. For example, a gambler's fallacy. This is where you flip a coin. Okay? Any coin you have that's properly weighed, okay, when you flip that coin, you have a 50-50 chance of getting heads or tails. But let's say you flip the coin 10 times, and 10 times in a row, heads came up. What are the odds on the 11th time that heads are going to come up again, or you'll get tails on the 11th time?
I would say you would probably get tails.
But what is the percentage? Or maybe you don't understand that yet.
I'm going to say...
If it's 50-50...
Well, 50 divided by 10?
No, don't do any of that. Okay. All right, I'm just going to tell everybody. Okay, good try. Okay.
Thank you.
We're moving on. Okay. A lot of people will think, well, gosh, it's been 10 heads in a row. So it's got to, on this 11th one, the odds of it being a tail have got to go way up because we've had so many heads in a row. And really, that's a gambler's fallacy. Every single time, no matter how many times heads has come up in a row, the 11th attempt will still be a 50-50 shot as to whether or not you would have heads or tails every single time you flip the coin. So. Well,
basically what you're thinking is come on, it's been heads 10 times.
Right. You're thinking that, but you'd be wrong to think that you have any greater chance of getting tails on the 11th flip.
Yeah.
Okay. All right. Here's another example. Here we're asking you to unscramble this series of letters right here.
Isn't it like psychology?
Okay. Good. You saw it. Okay. It's not very hard to unscramble, but if you use an algorithm, what you're going to do is start off. And you're going to start to try and figure out all 907,208 possible combinations of these letters.
Oh my God.
And that would take a very long time.
Yes, it would.
Okay. A heuristic is going to help you move faster. We know, for instance, we have a rule of thumb that in our language, we don't have any words with YY. So we have two Y's here. So we can throw out every single possibility where we have a word that we're checking that might end or begin or have YY in the middle of it. We wouldn't have that. So you would be reducing the number of times you would have to check using your algorithm. Okay? Whoop, golly, I'm sorry, everyone. All right, but anyway, that's a heuristic. All right, and last here, I think this is the last part I'm going to talk about, is insight. Insight is a sudden and often novel realization of the solution to a problem. All of a sudden, you just sort of, it's that aha moment, okay? Now, it does contrast with strategy-based solutions, okay? Strategy means you actually have an idea, I'm going to do this, and then I'm going to see how that works, I'm going to try this, and then I'm going to try this. Insight is sort of like you're almost stuck, and you're just sort of looking at a problem, and then you haven't really tried too many things, or maybe you have tried anything, but you're not currently doing it, and you just have an aha moment on how to solve it.
Kind of like you're reading through this really hard question, you try like 5 things, and you're like, that's what it wants me to do.
Right. Here's my example. I want you to read, I want you to tell me what these words together, this is kind of a mind game. I want you to tell me if this means something to you, if you can possibly get it in your aha moment. So you have you, just, me. Do you have any idea what that might mean? There's another meaning there. There's another meaning. It's using words and sort of pictures sometimes to create a different meaning. I
have no idea what you just mean.
Okay. So you're going to like this in a moment. You'll get the aha moment when I give it to you. But those of you out there who have played these games before, you will know that here you have, I forget exactly what they call them. I looked it up earlier and I totally forgot what it's called. But anyway, this is a word game, and it's, you would say here, just is in between you and me. So you say just between you and me. You see the phrase? Just between you and me. Get it?
Oh my God, that is
okay.
That is cool. That is so cool.
Okay. Well, some of you may have been looking at it wondering, what is that? What is that? And then some of you had that, boom, you just saw it. And you can't really explain how you saw it. It's insight, okay? Sometimes, what?
I would just be surprised if someone just look at it and like, oh, okay.
Yeah.
I don't know what it means. Because like, how can you just figure out you just mean,
Well, it's insight. That's what I'm trying to tell you. It
three,
exists.
It sounds like 3 random words.
Right. Can I get on with this now?
Sure.
Okay, thanks. Okay.
Okay.
Here's another one. Sometimes when playing a video game, insight is needed to get to the next step after an obstacle is placed in front of you. How many times I mean, you guys are definitely a video game generation. I was the beginning of it. You've been playing a game and you're stuck on a level and you keep playing it and you're getting frustrated. You can't figure out why. You can't move on. And then you have just this aha moment where you go, I haven't tried this. Boom. You figure out the level and you move on. Okay? Here's some more examples. This was an experiment with a chimpanzee by Wolfgang Kohler. Obviously, I think he's German. Where he was observing if chimpanzees have insight, and sure enough, it showed that they do. Here he had, I think is that a banana? I forgot. It's a fruit. Something. Yeah, I think it's a banana the chimp wants. And he just put the chimp in this room with his banana strung up over its head, and obviously he can't get to it. It's too high for the chimp to just reach up and grab it or jump and get it. And he just put some objects in the room to see if the chimp could figure out, hey, maybe something else would work. And sure enough, the chimp ends up building, using the apple crates there to build a tower and get to the banana. Insight. Pretty cool.
They should have used another animal because chimps go to outer space, don't they?
Well, not this one. This one goes to the banana. Okay.
Well,
they have a different chimp for that. Not all. It's not all the same chimp.
Yeah, I know.
Okay. All right. So I'm going to stop there for this video cast, and then we'll pick up the next one with fixation. Thanks a lot. Talk to you soon. Bye.
Bye, guys.